So in this video, we're going to continue our test 4 review. We're going to start with number 16. So number 16, in crossbreeding pea plants, Mendel found that the characteristic tall dominated the characteristic short. If we cross pure tall plants with pure short plants, what is the probability of tall plants in the second generation? So problem number 16. So we're starting with a first generation. We're breeding pure tall with pure short. So this is our first generation. So this is the first generation. So if I breed a pure tall with a pure short, then we're going to end up with tall, short, tall, short, tall, short, tall, short. And since tall is dominant, that means all of these first generation plants would be tall. So now in the second generation, if we breed these tall shorts, then I'm breeding a tall short with a tall short. So in this box, I would get tall, tall. In this box, I would get tall, short. In this box, I would get tall, short. And in this box, I would get short, short. So again, because tall is dominant, these three of the four would be tall. So the probability of getting a tall pea plant on the second generation would be 3 out of 4. So the answer is it would be a 3/4 probability that if I breed these two tall short second generation pea plants, there would be a 3 out of 4 probability that we would end up with a tall pea plant. Let's take a look at number 17. So 17 has two parts. We have part A and part B. Part A, if the odds against the Dodgers winning the World Series are 17-2, what is the probability of them winning the series? So 17A, again, we have the odds against being 17-2. 17-2. So this is against, this is for. Now these are odds. So if I want to find the probability of the Dodgers winning, the probability would be the 4, which is going to be 2 out of the total, which would be 2 plus 17. So that would be a 2/19 probability that the Dodgers will win the World Series. So it is a 2/19 probability. If we take a look at part B, if the probability of rain tomorrow is 0.55, what are the odds against rain? So we're given the probability for rain. So the probability for rain is 0.55. So that means the probability against rain is going to be 0.45. So the ratio of against to for is 0.45 to 0.55. So the odds against rain tomorrow is going to be 0.45 to 0.55. Now we don't generally like to leave it with the decimal point there. We like whole numbers. So if I were to multiply both of these numbers by 100, that would be 45 to 55 odds against rain. And we could reduce that. 45 and 55 can both be divided by 5. 45 divided by 5 would be 9. And 55 divided by 5 would be 11. So that would be 9 to 11 odds against raining tomorrow. So the odds, 9 to 11. Now I wrote this with the word 2. We could also write that with a colon. So we could say 9 colon 11. We could also write that with like a fraction, 9 to 11 odds. So we have those different options of writing it. Let's take a look at number 18. If a single card is drawn from a standard 52 card deck, what is the probability that we obtain either a face card or a red card? So on number 18, we're drawing one card from the deck. Our question is, what's the probability we get a face card or a red card? Well, face cards and red cards are not mutually exclusive. So this would be the probability of a face card plus the probability of a red card minus the probability of being a face card and a red card both. Now I use the word or here. I could have also used the union symbol. So face union red is the probability of face plus the probability of red minus the probability of face intersect red. Well, there are 12 face cards in the deck of 52 cards, so the probability of getting a face card would be 12 out of 52. There are 26 red cards, 13 are hearts and 13 are diamonds, so there are 26 red cards out of 52, so the probability of getting a red would be 26 out of 52, or 1/2 if we were to reduce that. Now, we looked earlier at the red face cards, and there are 6 red face cards, so we would subtract the 6 red face cards. So we're subtracting what face cards in red have in common. Well, so I have a common denominator of 52 here, so if I have 12 plus 26 minus 6, that's going to be 32, so that is 32 out of 52. And we can reduce that. 32 divided by 4 is 8. 52 divided by 4 is 13. So that is an 8/13 probability. Or if we prefer, we could write that as a decimal. 8 divided by 13 would be about 0.615. So this would be the same as a 0.615 probability. So the probability of getting a face card or a red card would be 8/13 or approximately 0.615. Let's take a look at number 19. On the given spinner, each green sector occupies 10% of the circle. So we have 3 green sectors, numbers 2, 9, and 5, and those each take up 10% of the circle. Each blue sector occupies 12%, so we have 4 blue sectors, 3, 6, 8, and 10, and each one of those takes up 12% of the circle. Each red sector occupies 9%, so we have 2 red, and those each take 9%. Those are numbers 1 and 7. And the yellow sector occupies 4%. We only have 1 yellow sector, number 4, and it's occupying 4%. Assume that the spinner is spun once. What is the probability that A, the spinner does not stop on red, B, the spinner stops on an even number, or blue? So if it doesn't stop on red, now again, what it told us here is that each red sector occupies 9% of the circle. So this red sector is occupying 9% of the circle. This red sector is occupying another 9% of the circle. So 18% of the circle is occupied by red sectors. So if I look at number 19A, the probability of landing on red is going to be 2 times 0.09, the 9%, and that is 18%. So the probability of landing on red is 18%, or 0.18. So the probability of not landing on red is going to be 1 minus that. And so that would be 0.82, or 82%. So if I spin the spinner one time, there is an 82% chance, or 0.82 probability, that the spinner will not land on red. B wants to know what's the probability the spinner stops on an even number or blue. So B, what's the probability we stop on an even number or a blue sector? Well, this is a lot like the previous problem we just did. This is going to be the probability of landing on even plus the probability of landing on blue minus the probability of landing on even intersect blue. So let's figure out what the probability of landing on even is. So I'm going to do that down here. What's the probability of landing on an even number? Well, that means it would be landing on numbers 2, 4, 6, 8, or 10. Well, if we look, 2 is green, and green represents 10% of the circle. 4 is yellow, and that is 4% of the circle. 6 is blue, and blue represents 12% of the circle. 8 and 10 are also blue, also occupying 12% of the circle. So the probability of being even, again, is going to be the probability of landing on 2, which again is green, and that's 10% of the circle. The probability of landing on 4, well, that's yellow, which is 4% of the circle. The probability of landing on 6, 8, or 10 is each 12% of the circle because they're each blue. So we're going to have 3 0.12s. Now, if we add that up, that is going to be, well, first of all, 3 times 0.12 is 0.36. 0.36 plus 0.04 is 0.40, and 0.40 plus 0.10 is 0.50. So there is a 0.50 probability that the spinner is going to land on an even number. Now, what's the probability it's going to land on blue? Well, the probability it's going to land on blue, there are 4 blue sectors, and each of those blue sectors represents 12% of the circle. So that's going to be 0.12 plus 0.12 plus 0.12 plus 0.12, or I'm going to say 4 times 0.12. So that is a 0.48 probability. But what's the probability that it's both even and blue? Well, if I look back here, 6, 8, and 10 are even and blue both. Again, each of those occupy 12% of the circle. So that's going to be 3 times 0.12, which would be 0.36. So the probability of even, we figured out, is 0.50. The probability of blue is 0.48. The probability of even and blue both is 0.36. So if we add up and subtract, 0.50 plus 0.48 is 0.98, and 0.98 minus 0.36 is going to be 0.62. So this equals 0.62. The probability that the spinner lands on even or blue is 0.62. Let's take a look at number 20. If a pair of fair dice is rolled, what is the probability that we roll a total of 5 if we are given that the total is less than 9? So number 20, we're looking at a conditional probability. We want to know what's the probability we get a 5 given that the sum is less than 9. Well, let's take a look at this on all of the possible outcomes. So here I have all of the ways that the dice could land. We listed some of these earlier in this review, but these are all of the 36 different ways that the dice could land. So if we're given that the sum is less than 9, then that means it could be anything here. This is 9, this is 9, 10. Nothing over here is allowable because we know we're less than 9. Incidentally, 9s aren't included because it's less than 9. So we know that it's in these outcomes right here, which there are how many different outcomes? Well, here's 6, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So there's 26 different results that are less than 9. So it's something out of 26. So I know right now this probability is something out of 26. Now how many different results have a sum of 5? Well, this has a sum of 5. So here's a sum of 5, here's a sum of 5, a sum of 5, a sum of 5. So there are 1, 2, 3, 4 sums of 5 out of the 26 different ways that we could get a result less than 9. So if we're given that it's less than 9, we have a 4 out of 26 probability. 4 out of 26 can be reduced. 4 and 26 are both divisible by 2. 4 divided by 2 is 2. 26 divided by 2 is 13. So there is a 2/13 probability. And if we take 2 divided by 13, that is about a 0.154 probability. So this is about a 0.154 probability. So 2/13 exactly, approximately 0.154 probability. Let's take a look at number 21. Assume that 2 cards are drawn without replacement from a standard 52 card deck. What is the probability that 2 hearts are drawn? What is the probability that a queen and then an ace are drawn? So problem 21, part A, we want to know what is the probability that we get 2 hearts. So the probability of 2 hearts. Well, then that means that the first card has to be a heart and the second card has to be a heart. So we're going to use the multiplication rule here. The probability that the first card will be a heart, well, there are 13 hearts out of the 52 cards in the deck. And then assuming that we got a heart for the first card, for the second card there'll only be 12 hearts left in the deck, and there's only 51 cards left in the deck. So we have 13 out of 52 times 12 out of 51. Well, we can simplify this before we multiply. 13 will go into 52 4 times, so 13 out of 52 will reduce to 1/4. 12 and 51 can both be divided by 3. 12 divided by 3 is 4, and 51 divided by 3 is 17. And then this 4 and this 4 can divide out. So we're left with 1 times 1, which is 1, and 1 times 17, which is 17. So we get a 1/17 probability. Or if I change that to a decimal, that is about a 0.059 probability if I round to 3 places. So this is approximately 0.059 for the probability. For part B, again, we want to know what is the probability that a queen and then an ace are drawn. So notice this order matters. It's got to be a queen first and an ace second. So this is the probability of getting a queen, then an ace. So a queen first and ace second. Well, the probability of getting a queen for the first card is going to be 4 out of 52 because there's 4 queens in the deck of 52 cards. And now assuming that we got a queen on the first card, well, there's only going to be 51 cards in the deck, then 4 of those are going to be aces. So the probability that the second card will be an ace, assuming the first card was a queen, will be 4 out of 51. So if we multiply these two things, this will give us our result. Well, 4 and 52 can reduce. 4 goes into 52 13 times. Nothing else can be canceled there. So we're left with 1 times 4, which is 4, and 13 times 51 is 663. 13 times 51 is 663. So we have a 4 out of 663 probability. And so if I take 4 divided by 663, that is approximately 0.006 if I round to 3 places. So this is 0.006. So the exact probability, 4 out of 663, or approximately 0.006. Let's take a look at number 22. A pair of fair dice are rolled. Are events E and F independent? E, an odd total is obtained. F, the total showing is less than 6. Well, to do this problem, again, event E is saying that we have an odd total, so I'm going to just write odd. And event F is that we get a total of less than 6. So in order to determine if these two events are independent of each other, we need to find their probabilities and see if the probabilities change. What I mean by that is we want to find the probability of F. We also want to find the probability of F given E, and we want to see if those are the same. If these two probabilities are equal, so I'm going to say if these are equal and put a question mark on it, if these two probabilities are equal, then that means the two events are independent of each other. But if these two probabilities are not equal, then that means these two events are not independent. They would be dependent. So how do we find the probability of F? How do we find the probability of being less than 6? Well, let's take a look at our dice figure again. So I've got a new dice figure here. So there are 36 different ways that the dice could land, and of those 36 ways, anything above here is less than 6. This is 6 or bigger. Anything above here is less than 6. Anything below is 6 or bigger. Anything above here is less than 6. And anything above here is less than 6. Again, anything below is bigger. So this is 6. Anything over here is bigger. So there are these outcomes here that are less than 6. So of the 36 different ways the dice could land, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different outcomes that are less than 6. So the probability of getting a result less than 6 is 10 out of 36, which we can reduce. 10 and 36 can both be divided by 2, and so 10 divided by 2 is 5, 36 divided by 2 is 18. So that is a 5/18 probability. Now, what if we know that we have an odd result? Well, taking a look here again, think about the odd numbered results. That's the given. Well, this is an odd result. This is an odd result. This is an odd result. These three are even. This is odd, even, odd, even, odd, even, even, odd, even, odd, even, odd, odd, even, odd, even, odd, even, even, odd, even, odd, even, odd, odd, even, odd, even, odd, even. So there are 18 different odd results. So 18 different results where the total is an odd number. Now, of those 18, 1, 2, 3, 4, 5, 6 of them are less than 6. So the probability of getting a total less than 6, given that we have an odd numbered result, will be 6 out of 18. So in other words, this probability here is 6 out of 18. Now 6 out of 18, that can reduce. 6 and 18 are both divisible by 6. 6 divided by 6 is 1. 18 divided by 6 is 3. So that probability is 1/3. So if I know I have an odd numbered total, the probability of being less than 6 is 1/3. If I don't know that, the probability of being less than 6 is 5/18. So those two probabilities are not equal. So our question was, are the events E and F independent? So the answer to that question is no. These are not independent. These are dependent events. Now let's take a look at number 23, and let's do that on a clean sheet. Number 23, suppose a container holds 10 ping pong balls, of which 7 are white and 3 are yellow. If 2 balls are drawn from the container, what is the probability that 1 will be white and 1 will be yellow? Now this is a little bit of a trick problem, because notice it's saying 1 is white and 1 is yellow. It's not saying which one's white or which one's yellow. It's just asking what's the probability that we have 1 white or 1 yellow. So there may be more than one way that can happen. We got to pay attention to that. So number 23. So again, we know that we have 7 white and 3 yellow balls. So I'm going to think about the first ball, and I'm going to think about the second ball, and I'm going to draw a tree. So it's possible that the first ball could be white or the first ball could be yellow. Those are the only two possibilities. Now if the first ball's white, the second ball could be white or the second ball could be yellow. And if the first ball's yellow, the second ball could be white or the second ball could be yellow. So we have a tree diagram here. Now the probability that the first ball is going to be white will be 7 out of 10 because there are 7 white balls out of the 10 balls. And the probability the first ball will be yellow will be 3 out of 10 because there's 3 yellow balls out of the 10 balls. Now if the first ball is white, what's the probability the second ball will be white? Well, if the first ball is white, then that means there's only 6 white balls left in the bowl, and there's only 9 balls left in the bowl. So this probability would be 6 out of 9. If the first ball is white, the probability the second ball will be yellow. Well, there's still 3 yellow balls in the bowl, but there's only 9 balls left in the bowl. If the first ball is yellow, what's the probability the second ball will be white? Well, again, if this is yellow, then there's still all 7 white balls in the bowl, but there's only 9 balls in the bowl. So that would be a 7/9 probability. And if the first ball is yellow, the probability the second ball will be yellow. There's only 2 yellow balls left in the bowl, and there's only 9 balls left in the bowl. So what I'm getting at is the probability of getting white is going to be 7/10 times 6/9. The probability of white yellow is going to be 7/10 times 3/9. The probability of yellow white is going to be 3/10 times 7/9. And the probability of yellow is going to be 3/10 times 2/9. So we can figure out each one of those. Well, let's see. 6 and 9 can be reduced, so we can divide both of those by 3. So that's going to be 6 divided by 3 is going to be 2. 9 divided by 3 is going to be 3. And then 2 and 10 can both be divided by 2, leaving 5 and 1. So I got 7 times 1, which is 7, 5 times 3 is 15. So there's a 7/15 probability that we'll get both white balls. The probability that the first ball will be white and the second ball will be yellow, again, I can cancel here. So I get 7 times 1, which is 7. 10 times 3 is 30. There's a 7/30 probability that we'll get the first ball white and the second ball yellow. Well, the probability the first ball will be yellow and the second ball will be white will be 3/10 times 7/9. Again, we can cancel here. 1 times 7 is 7. 10 times 3 is 30. So we have a 7/30 probability for that as well. And the last possibility was yellow, yellow. Well, again, I can cancel here. 3 will cancel with the 9, leaving 3. 2 will cancel with the 10, leaving 5. 1 times 1 is 1. And 5 times 3 is 15. So there's a 1/15 probability that we'll get yellow, yellow. Now, again, our question was, what is the probability that one will be white and one will be yellow? Well, one white and one yellow means it could be this or it could be this. So what we're really looking for is what's the probability it's this or this? Well, that will just be these two things added together. So the probability of one white and one yellow means it could be white-yellow, which would be 7/30, or it could be yellow-white, which would also be 7/30. Well, 7/30 plus 7/30 would be 14/30, which can reduce. 14 and 30 can both be divided by 2. 14 divided by 2 is 7. 30 divided by 2 is 15. So that would be a 7/15 probability. So the probability that we would get one white and one yellow is equal to 7/15. And if we prefer, 7 divided by 15 is about 0.467 if we round to 3 places. So this is about 0.467. So exactly the probability is 7/15, or approximately 0.467. So this finishes the solutions to the test for review.